How are you? I'm good, thank you. And welcome back to my channel. I am Saiasmi Gupta, co-founder of 10x for the Kids. Today we are not doing coding. As you must have read the title, we are going to today do learn the distance time graph. There are a lot of questions which come on this and this is really going to help you in the future classes as well. So without any delay, let's get started. Right. So, distance, time, graph. Right. Sorry if my handwriting is not too good in this. One second, I'm gonna clear the page out. Right. So, first we are gonna learn about the uniform motion graph. Uniform motion. So basically, what is uniform motion? Covering equal distances in equal intervals of time. Let me show you. Perfect. Okay, so this is the x-axis, right? This is the y-axis. And today we are gonna do it kilometer per hour, okay? I'm so sorry, guys. So let's do the divisions. 2, 3, 4, and 5. I'm sorry I have unequal distances here, but I guess we'll have to work with it today. Right? And this is the distance. Okay? And here we have the time. Okay? Right? So, first in a car driver was basically driving a car, right? And he covered 1 kilometer in 1 hour, then second kilometer in the second hour, third kilometer in the third hour, fourth kilometer in the fourth hour. This should be like this, and fifth kilometer in the fifth hour. So he was doing 1 kilometer per hour, right? So he was traveling the equal distances. He was covering equal distances in equal time, right? So now these points of intersection you see here, we're going to join all these points, right? We join all these points, and this here we have it. We have made a uniform motion graph, right? So now basically I'll just I'll just make a easy one here. So basically the result we came out of was this. Oh, sorry. Perfect. So this is what we got, right? So this was the uniform motion graph. Right, guys? One second. I'm going to clear out the page. Give me 2 seconds. Let's just remove this heading also. Who needs it? Absolutely perfection. So now we're going to learn about non-uniform graph. It's a bit tricky, but we got it. So, non-uniform. Now I'm going to do it pretty nicely so that it does not look weird and very messy. Right. So, let's do. So we have two graphs in non-uniform graph. Perfect. We know this. This is not the x-axis. This is actually the y-axis. My bad. This is the y-axis. This is the x-axis. Here we are going to denote the time. Here we are going to denote the distance. Right? So we have 0, 1, 2, 3, 4. 1, 2, 3, and 4. Now, I know these divisions are unequal, but today we got to work with it. Perfect. So, what the non-uniform motion says is it covers unequal distances in equal intervals of time, right? So, it's covering here, it's covering 0.1 kilometer in 1 hour. Okay, then what it's doing is it's covering 0.5 kilometers in the second hour. It's covering 1 kilometer in 3 hours. Oopsie doo. Now 1 kilometer, the first kilometer in the third hour. Then in the fourth hour, it's covering 2.5 kilometers, right? 2.5 kilometers. So you saw first it was covering 0.1 kilometer in 1 hour. Then 0.5 kilometers in the second hour. Then first 1.0 kilometer or 1 kilometer in in the third hour. Then 2.5 kilometers in the fourth hour. So the time gap is of 1 hour each, but we are covering unequal distances, as you can see here, right? So this was one type. Now there's another type in non-uniform motion. Okay, I'll show you. Perfect. So let me show you. So look, let me make the graph. This is the x-axis, this is the y-axis. Here we're going to denote the time. Here we're going to denote the distance. Okay? So this is 0, 1, 2, 3, and 4. 1, 2, 3, and 4, right? Now this type of graph goes like this. It's a bit tricky. Sorry. Oh. I could have done that. So, oh god, sorry, it's not 1 second. Right. So here you see what it says is it covers basically unequal distances in equal intervals of time. So in 1 hour it's covering 2.3 kilometers. In 1 hour, in the first hour, it's covering 2.3 kilometers, as you can see. In the second hour, it's covering in the second hour it's covering 3 kilometers, right? In the third hour, oh sorry, I made the graph a bit wrong. Oops, daisies. Right. So this is better, okay? So in 1 hour, it's covering 3 kilometers. In the second hour, it's covering 4 kilometers. In the third hour, oh god, I'm making it wrong again and again. Gosh, silly me. Yeah, that should be better, I guess. So in 1 kilometer, in 1 hour, it's covering 2.3 kilometers. In the second hour, it's covering 3.5 kilometers. So basically 2.3 kilometers and 3.5, right? 3.5 minus 1.2 kilometers. In the next hour, it's covering 1.2 kilometers. 1.2 kilometers. In the third hour, it's covering 4.2, right? So 4.2 minus 3.5. 3, 12, 11, 10, 9, 8, 7. 0.7 kilometers. Right? It's covering 0.7 kilometers. So just like that, in equal intervals of time, we are covering unequal distances. Now, we are not going to go in the deep of this, because when you go, guys, actually I'll also go in the higher classes, we'll all learn about, basically in these graphs, it goes in a dip like this, right? So then we do negative, right? So right now we don't know about it, so, and it's not in our syllabus, so we're just gonna leave that, right? So that was the second type of non-uniform motion. And like that, we have covered uniform motion and non-uniform motion graph. Next graph that we have is this. I'll show you. And this and this. Y axis, this is the x axis. This is the time. Here is the distance, right? So here a line here. Perfect. So here sometimes people get confused. Look, I'll show you. 0, 1, 2, 3, 1, 2, 3. Sometimes people think that this is the starting point and first the person goes up, covers 3 kilometers, and then it goes and then it stays still. Now you might be thinking, what am I just speaking? So I'll explain you. Basically, this represents, this line represents staying still, zero speed. Now you might be thinking, what gibberish is this? I know. So this point is the starting point, okay? Right? And from here, the graph is not going up, it's not going up, right? Neither is it going down, it's right here. That means that we are not moving, we are still. That means this graph is representing zero speed. What is it representing? Zero speed, right? That means no motion. Okay, so this is what that graph says. Remember that the starting point is from here in this graph. I'll just erase it, it's a bit too much, right? Okay, so next graph that we have is going to clear your concepts even more. Hairline, this and that, and x-axis and y-axis, right? This is 0, 1, 2, 3, 4. 1, 2, 3, 4. Right? Now, here it's kind of tricky. Oh wait, I forgot to tell you. Okay, I'll tell you later about it. Look, there's some graphs like this. First like this. Now what is this graph representing? This graph tells us that this is the starting point. From here, I'm so sorry guys. Let's take it that it is 2 kilometers, right? And that the person first covered 2 kilometers in 2 hours, right? The person covered 2 kilometers in 2 hours, okay? Then the person is still. Wait, I'll show you. Oh wait, why did I erase it? The smallest one actually here. Right. So now after covering 2 kilometers in 2 hours, the person is still. Okay, now the person is still. He is not moving from here. Then he is going down. He is going minus 2 kilometers. Whenever in a graph you're going downwards from up to down, that means it will be done in minus. So it will be denoted in minus. So then, as we know, it took him 2 kilometers, so it will take him minus 2 kilometers to get back down in another 2 hours, right? So that is what it is. Okay,